Hello again and welcome to the third lesson on functions for this week, the final lesson on functions for now. We've looked at domains, ranges, we've looked at mappings, we've looked at one-to-one functions, many-to-one functions, we've looked at inverse functions, and now it's the turn of composite functions. So a composite function is a function that's made up of two or more functions and they're being put together. We've looked at composite functions so far when we've done differentiation using the chain rule, which I referred to a little in the video for the chain rule, but I didn't go into too many details. Now we're going to have a look at the actual functions themselves. And the best way to do it is to get stuck into some questions. So in this question, we're told that f of x equals x squared, where x is in the set of real numbers. That's the only thing we're told about the domain of x. It can be any real number. And then we've got g of x, our next function, which is x plus 1, and again, where x is in the set of real numbers. So again, that means that x can be any value that's a real number. So in order to work out what the question is asking us here, we're asked to find fg of 1. Now, I'll rewrite this question, and I tend to rewrite them in a certain way because I think it makes more sense to me, and it tells me what I'm supposed to do. So I'm going to write this as f. And then inside the bracket for f, I'm going to put g of 1. And that's telling me that I'm doing g of 1 first, and then I'm substituting in to f. So I'm going to sub g1 into the function f. So let's have a look. So g of 1 is where we substitute 1 in for x here. So 1 plus 1 is 2. So g of 1 is 2. And then that means that I'm going to be working out f2, which is 2 squared, which is 4. So work out the second one first, substitute into the first one. Let's do the same thing for part B. So this time we're working out g of f of 3, which means we are going to substitute f of 3 into g this time, other way around. We can work out that f of 3 is going to be 3 squared, which is 9, which means we're working out g of 9, which is 9 plus 1, which is 10. So then we've got f minus 2. And for f, what we're doing is f of minus 2. So we're going to work out what f of minus 2 is, and then we're going to substitute the answer back into f again. Okay? So f of minus 2 is minus 2 squared. That's the f function, which is 4. And then f of 4, again substitute into the f function, which is 16. So as long as you get them the right way around, these composite functions shouldn't cause you any problems whatsoever. And my recommendation is that you rewrite the question using these brackets so that you know exactly what it is you're supposed to do. So let's have a look at some more general examples then, where we're using algebra rather than evaluating the function. So we're told here the functions f and g are defined this time as f of x is 3x plus 2. Again, x is in the set of real numbers, so it can be any real number. And g of x is x squared plus 4. And once again, x is any real number. Okay, no other limits have been imposed on us in those two domains. Now we're being asked to find fg of x, the general function. So I'm going to write fg of x then, using my extra brackets, so f of g of x. And that means I need to substitute g of x into the function f. So let's do that. That means fg of x is going to be as follows. So f of x is 3 times x plus 2. That means wherever there's an x, we times it by 3, and then we add 2. But this time, we're not substituting x in, right? We're actually substituting x squared plus 4. So our function becomes f of x squared plus 4, which is going to be 3 multiplied by x squared plus 4, then add 2. Now that's simplified. That's as far as we can go with simplifying it, but we can rewrite it. We can expand the bracket out and make it look more complicated. We get 3x squared. 3 times 4 is 12, plus 2 plus 14. So that's f g of x. Take g of x, substitute it into f, which looks like this. Part B, we're going to do g f of x, which is g of f of x. And the technique is we're going to substitute f of x into our function g. So this time, we're going to do this. G f of x is going to be g of 3x plus 2. And that means we look at the function g, and instead of x, we're going to use 3x plus 2. So this x squared plus 4 becomes 3x plus 2 squared plus 4. So the 3x plus 2 has replaced the x. That's where we are. And again, it's been fully simplified, but we can expand the bracket to get 9x squared plus 12x plus 4 plus 4 plus 8. Either one of those two is fine. Next, we've been asked for this, which is quite interesting, f squared of x. Now, f squared x is f of x, just like we did in the last example. It's just another way of writing it. So we're going to substitute f of x back into f. Now our function f of x was 3x plus 2. So that means f squared x is f of, forgotten it already, 3x plus 2, which is going to be equal to 3 times 3x plus 2 plus 2. You see how the x has been replaced by the 3x plus 2. And again, this looks fine, but we'll expand the bracket and collect the terms. So we have 9x plus 6 plus 2. So we've got 9x plus 8. So for part D, find the values of b such that FGB equals 62. So first thing to do really is write down what FGB is. So FGB is where we take b and substitute into fg of x. So we'll have, instead of 3x squared plus 14, which was our fg of x, we'll have 3b squared plus 14. And we're told that this is equal to 62. That's given to us in the question. And now it's just about solving this little equation. So we'll take 14 from both sides, and then we'll divide both sides by 3. And then we'll take the square root. So b can be plus or minus 4. That is a b and not a 6. So that's your tour through composite functions. They don't, the questions can get a little bit more technical than that, but that's certainly the skills that are underpinning the whole thing. And I think the rest of them shouldn't cause you too many problems. So as ever, post questions in the chat in Teams, and I'll see you in the lesson.